In today's video, we're going to identify how to find the domain and range of a function. The first thing we have to identify is what the words domain and range mean. Domain represents the set of all inputs, or our x values. The range represents the set of all of our outputs, or our y values. So when we look at a set of ordered pairs and we want to identify the domain, what we do is list out all the x values. So I'm going to go through and I'm going to highlight the x's in -2, 0, 4, 5. I'll list those in order from least to greatest. The smallest of those numbers is -2, then 0, then 4, then 5. If there are any repeats, we just don't repeat that number. I'll go ahead and start my range. My range would be my list of all of my y values. So I'm going to highlight the y's. And those numbers in order listed out from least to greatest. The smallest number is 0.5 and then 2.5. Notice 2.5 repeats itself here and here. We don't need to list that twice, so we just go right ahead to list out 6.5. Again, we can make a mapping of this. So we would put all of our inputs, -2, 0, 4, and 5, in the left circle. And we can put all of our outputs, 0.5, 2.5, and 6.5, in our right circle. To draw the mapping, we would take -2 and we would send it to 0.5 because in the ordered pair, -2 goes to 0.5. 0 goes to 2.5, so we draw an arrow there. 4, we draw an arrow from 4 to 6.5. And then for 5, we're going to draw an arrow back to 2.5. To determine if this is a function, to review, we ask ourselves, does each input have exactly one output? So I look at the x values, or the inputs. Sorry, whoopsies. There we go. Okay, I'm going to look at each of the inputs and I ask myself, do they all just go to one location? The answer to that is yes. So we have a function. All right. If this is listed out in table format, it makes it a lot easier, honestly, because our x's are all in the left side of the table and our y's are listed in the right side of the table. So for our domain, we go ahead and list out all of our x's in order from least to greatest. So the smallest number is 2, then 3, then 5, then 6. Again, you don't need to relist repeats, so the 2 only needed to get listed once. Okay, the range, go ahead and list out your y values in order from least to greatest. So we go 1, then 4, then 7, then 8, then 10. If we want to determine, is this a function, we're going to check the x values, see if there's any repeats. Notice that the 2 repeats, and the 2 has to go to the same exact number. That way it only has one output, but 2 is trying to go to 7 and to 1. So therefore, this is not a function because 2 has 2 outputs. Okay, so that's when we have a list of ordered pairs or a table. We're going to move on to determining if the domain and range from a graph. I think it's easier to do the graphs that look like points first. Okay, I find these ones the easiest because when we try to list this out, I think for me, if I have a bunch of points, what I do is I just label those points. So I'm going to identify this point. The yellow point is, it looks like that's 0, -2. The green point looks like it's 0, the yellow point is 0, -1. The green point looks like it's 0, -3. The blue point looks like it's 0, -6. And then the pink point looks like that one we can label as 11, 0. So now that I have these points, these are all the points that are on my graph. I'm going to do the same thing that I did before for listing my domains. So my domain is all of my x values. So for this example, I have x values of 0 and 11. And then the range is going to be all of my y values. And for this example, from least to greatest, it goes -6, -3, -1, and 0. Is this a function? We can look at those x values and just check to see if they go to the same number every time. But it looks like 0 has 3 different outputs. So 0 goes to -1, -3, and -6. So our answer is no, because 0 has 3 different outputs. Okay, we could also have done the vertical line test for this. So if we draw a vertical line through the y-axis, we can see that that touches 1, 2, 3 points. So then this fails the vertical line test, so it's still not a function. And over here, I'm going to go ahead and skip to I, because I think for the explanation it makes it a little bit easier. Okay, when I look at a graph that's where the points are all connected, it would be impossible for us to list out all the points that are on the graph. So we identify the domain and range a little bit differently for this. We're going to identify the domain and range using what we call interval notation. So interval notation is where you have, it looks like kind of like an ordered pair, right? And so you say we're going to go from, I don't know, from starting at 1 and then ending at 3. And then we have 2 different ways of listing the endpoints. So sometimes we want to include the endpoints and sometimes we don't. If we use a bracket, that's telling us we want to include the endpoint. If we use a parentheses, that's telling us we don't want to include the endpoint. So when would we not include the endpoint? We don't include the endpoint for open circles and for infinity symbols. Okay, so if we're saying, hey, this will go on for forever, we don't want to put a stop on that, so we would use a parentheses there. We do include the endpoint if it's a closed circle and it's just a simple number. Okay, so we look at example I. The domain, when we identify all of our values, domain is our list of our x values. So our x values travel left to right. So what we're going to do is we're going to identify how far left this point is. So it looks to me, if I kind of figure out, I go draw this up, it looks to me like this point starts at -5. And it's a closed circle, so I'm going to put a bracket on that -5. So if we look closely at this, that was a closed circle. And then I'm going to go all the way right to how far right is this point. This point goes all the way to 8. So when I do my interval notation for my domain, I'm going to say it goes from -5 to 8. And then both -5 and 8 should have brackets around them because those are both closed circles. Range is representing your y values, and our y values go up and down. So our range, we would go, how low does our graph go to how high does our graph go? So I want to ask myself, how low is this point? This reaches a value of -9. So for my range, I'm going to start at -9. And again, that point is closed, so it's going to be inclusive, so we'll use a bracket. And then what's the highest point? So this is where students usually get a little bit tricked because they want to use this right point, but it's not. We ask ourselves, what's the absolute highest point on this graph? And that's this point right here. We don't have a clear defined point, but I know that the graph reaches this height. So what is that height? That height is -2. So I'm going from -9 to -2, and -2 is inclusive because there's no open circle there. Is this a function? We can quickly check. Does this pass the vertical line test? and it does pass the vertical line test. Anywhere I draw a vertical line, I'm only going to pass through the graph one time. So yes, it passes the vertical line test. If you have further questions about the content from this video, feel free to talk to your teacher.